All right, first video, let's get down to it. We're just going to start by seeing a simple example of how you create a macro in Scala. We'll just play around with something silly with strings to get started. The reason we have two files here is because you can't define and use a macro in the same file. So we're going to define our macro here and then use it in the other file. So you start with an inline def, and we're just going to call it string things, string, and we are going to need quoted here. Now we have our expressor, and we're going to return an expression of a string. No, it's not right. This returns a string, and the other one returns an expression of a string. So string things equal. Sure. Okay. So this is splicing and quoting. We'll get into more of how that works in a bit, but this is how you move back and forth between things that are happening in compile world land and in runtime land. So this is a pretty common pattern that I see people using, like this. And because we've passed this here, this operator here is taking something that's a string and creating an expr of string. So when we use it here, it needs to be an expr of string, and we need to return an expr of string. And one other key thing here is that we need to have our quotes. Okay? So let's start here. We need to, I'm going to pretty quickly switch over to using my wrapper around the quotes library, but for now we will just use the raw library. And then let's just start here by doing macros.string things hello macro. Okay? So what do we got over here? Quotes reflect. Oh, it's not used. Okay. Port.error and abort string.show. Let me do that. Okay, perfect. So what we can see is this string here is the string that's right here. If I was to do something like say hi, now things get a little weird. This will be a little better, I think, if I do that. Yeah. So this is the expression that we have that's passing through. And notice that this is not actually like back when we were here. We're not actually passing the string. This is the expression of a string. Granted, the expression is just a constant. So why is not the first thing we can do is try and get that out. So what we can do is we can use this value or abort. And then if I do 2, now notice we don't have our quotes around it. This is just an actual string that we have in memory. Or in the actual literal string is in the compilation phase at that point. Let's get rid of that and see how we could make a new expression. I'm just gonna call it an expression. A new expression. So we're gonna make another expression here, and we're going to use some of these fun things here. So this is about the only time when you're going to be having the, this one, I think that's the splice, or the quote. One, I honestly don't know which is which. But generally, you're going to have this when you're creating expressions, and then this at the top level is only happening in the inline def. So let's do something a little silly, and let's just add string plus the other thing. And you notice, oh, this is not right. We have something at the wrong staging level. And the reason for that is because this is an expression of a string, and in here we need to have an actual string. And so the way we do that is the back and forth of this. So inside here, if we want to use an expression and have it be at the correct level, we need to splice it in. I'm gonna pretend that that's the right term. So now, if we do a show here, we can see that we've got some funky stuff now. We've got a string and an add and here. So we don't actually have what happens when you add the strings together. We have the expression of adding them together. But that's kind of inefficient, right? Like earlier we saw that we had it in memory, so why don't we just merge it? So what we can do instead is here plus that value or abort, like that, and then we'll show string 3. And what is that? Okay, so now we've been able to wrap the string. And this is all one expression. But what's going to happen now if I switch this back to say hi? Oh boy. Now things get messy again. There's only some times where you can actually get this value out. It's this thing called from expression. We'll get into that more later. The Scala people have defined one for string, but it cannot just extract any arbitrary value, and it can't run your code either, unfortunately. So it can only pull out an actual value from an expression if you have one of these from expers, and the from exper, or the expression actually is something that you've predefined that you can pull out. Generally, you don't need it to be able to do that. Generally, it's good enough to be able to just have like combine expressions into new expressions, but sometimes you need to do that. And in this case, we can't. So this is the point where I'm going to move to my stuff here. I'm going to get rid of this. I do not call this value abort. I call it eval, like so. All right. That is not right. I need to spell words properly. But we're going to ignore that for now. And, okay, so what can we do here? I have actually a helper that does this exact thing. So what specifically for combining strings. And so we're going to stick with stay high for now. What I'm going to do is I'm actually going to put these into a seq and stir, and another expression at the end. This is kind of the inverse of that value or abort or eval thing that I was just doing. And this is obviously not correct right now, right? Because we have a bunch of sequences. But there we go. It decided to stop being silly. Okay, so this expression makes string here. And so now we can see that we've got this whole string builder going on where we're adding the string and then adding this say hi and then adding another string and then we get the result. And it's built this whole expression for us here. And we can see what happens when we flip this back to say hi is now because it knew what all of those expressions were, we could actually just pull it out and extract it into one constant string. Okay, what else could we do here? Oh, let's do something fun. Let's say that we do need to our macro is going to require that it's a constant string. So we'll do this, and let's make it so that we print however many characters are in your string. It's going to be that many things long, we'll say. So we'll do fill string value. Let's do it like this. Go required dot length, and we're going to fill it with that many strings, and we're going to we need here, and now we can intersperse that, and then we get our, I don't know why it's being annoying about that, but I've generally not had issues with that, but it's going to be a pain today, apparently. Okay, so we can see here that it just does that, and if I say hello macro, now we've got a whole bunch of them. And I'm realizing that actually this could probably have been made easier if okay. It's gonna, instead of going through those two things with the intersperse, we could actually probably get rid of that and do the make string just like that, and we should end up with the same result here. Yes. Okay, so we can see here that it's printing it the same number of times as the length of the string, right? Let's see what happens if we go back and do this. Okay, now we are back to this whole misspelled issue. So what do we do? Let's try this. We'll do eval option, and we'll do either 5 or the number of the line. So now if we're here and I go like this, it's going to add AB twice, And if it doesn't know how long it is, it's going to do it 5 times. And we can see here that it's going to actually add your expression, not just a constant string. And it only merges things when it actually is able to evaluate it. If it's not able to evaluate it, it's just adding the actual expression. Okay, so let's take a look at what this is that I did here when I imported this oxygen quoted versus the Scala quoted and got rid of that import. So the way this quotes library works is that it's all located within a quotes instance. So it's all these nested types, and then you have this reflect, which is a reflect module, and you have to look within this trait, and everything is um, not implemented here. It's implemented in the compiler, and the way that they've chose to expose that is this way. Um, and I personally, and the reason that I created this wrapper, which we'll look at in a minute, the reason I did that is because, in my experience, IntelliJ cannot figure this out whatsoever. It gets very confused, and you're already in a very complicated world here with this. You're essentially working with stuff that's almost one to one with the compiler, as far as working with trees and symbols and stuff that we'll all get into in a later episode. But dealing with that level of complexity when the IDE is making your life harder on top of it is is just no good in my opinion. Um, so that's one of the things is the IDE can't figure it out in my experience, and the other one is that when you have these things, like if you try and get a tree, or if you try and get a symbol, it all needs to be scoped to this quote instance, which can get very difficult. Um, especially like if you're trying to write something that is a non-trivial program that needs to be calculated in a macro. Like for example, right now one of the projects I'm working on is another SQL library that's macro based that inspects your code and you just write it in normal Scala and it converts it to SQL for you. There's a lot of lines of code to do that, and you end up with huge files and like this using quotes at the top, and then using quotes at the top, and so all these classes and helpers are defined in one file because it gets very tricky to use these quotes across different files because of um, the the nested nature of it. If it's not just a symbol or a tree, it's this specific quote dot reflect dot tree. Um, and so what I've done is I've essentially copied the entire quotes reflect library and made them to be top level definitions. And so I can just outside of a quotes here do what's a good example? Um, if I have a term, I can get the type of that term by just doing term.type here. And then if I do that two term here, this is in this oxygen quoted, just some top level things. And when we print this out here, oh, it doesn't like that. We need to show it. And what is it not like now? Oh, it's not. Okay. Oh, interesting. Okay, so it's actually the type of it is, there we go. It was using a specific type, and so we have this function here called widen, which will get rid of the fact that it's referencing a literal string, and it'll just tell us that it's a string. Okay, so what are the key takeaways here? One is that macros are just normal Scala code. If you can write Scala code, you can write a macro. There's a little bit of boilerplate and barrier of entry knowledge wise to like figuring out, oh, this is how I do an inline def that references another function, that when things are expressions and when are they not, and all of that definitely takes a little bit of figuring out, but is honestly not too difficult. Um, the difficult part gets into when you actually try and use like figure out how to convert between these things and how to build what you're looking to do. But we're going to get into some great examples of how to do that in the next episode. We're going to implement show as a first study of macros. Um, for now, hopefully we can see this is how you make a macro.